All right, welcome back. Now we're going to actually do the calculations here. So I'm going to run through a couple of these. Mainly, I'm going to fill in the first row, and then I want to go and do a specific one that I see people make mistakes on. Now, I am going to be focused on pointing out mistakes. I'm going to show you specific things to do to make sure you don't make these mistakes. Okay? So, first and foremost, the Rankine conversion is really easy. Which equation do we use to go from Fahrenheit to Rankine? Well, it's going to be the only one that has Fahrenheit and Rankine in it. So R is F plus 459. So if F is 32, then we take 32 plus 459. And that is going to come out as, oh, hey, I should turn the pen on. Hey, I should know that by now. All right, and that is going to be 491 Rankine. Hang on a second, I'm burning up. All right, I feel much better now. Okay, so 491 Rankine is 32 Fahrenheit. Now, we cannot go from Rankine to anything other than Fahrenheit. There is no conversion up here that will take us from Rankine to anything else. So we can only go from Rankine to Fahrenheit. Likewise, we can only go from Fahrenheit to either Rankine or to Celsius. And Celsius to Fahrenheit, or Kelvin, and Kelvin can only go to Celsius. We have to move back and forth across this in a straight line. So now, if we want to finish filling this in, we need to do our Fahrenheit to Celsius conversion. So which equation do we want to use? Well, if we have Fahrenheit, we're after Celsius, there are two equations that have Fahrenheit and Celsius in them. By the way, these are the same equation, just one is solved for C and the other is solved for F. These two are how you're going to go back and forth between these two. I recognize that this equation is kind of a mess. I'm not going to ask you to do algebra on this. These two equations, though, you should be able to do the algebra for to solve for C or F when needed. I'll show you one of those in this video, but you should be able to do that on your own. Now, if we're going from F to C, we want the equation that is solved for C. So, we're going to use this equation here. Now, I'm going to show you a way to do this that makes sure you don't make mistakes. However, if you decide, that's dumb, I don't want to do that, you are welcome to make all the mistakes you want and get all the wrong answers. But I will tell you that most people make a mistake right here on the numerator. So, trust me, just follow along. Even though you probably already know what this answer is supposed to be. Just stick with me. I'll show you what's going on. Now, we have to use this equation to get our centigrade. So, we're just going to write this out. 160 minus 5 times F, which was 32.0. Don't forget, we don't want to lose that 0. That's how we knew this had to be 3 sig figs. Okay, we still need the 0. That is all over -9. So, the first thing we want to do is this. Ignore that negative sign. This is the most important tip I'm going to give you today. Ignore the negative sign while you resolve this part. 5 times 32. Well, 5 times 32 is going to be 160. Now we're going to bring this part back up. So 160 minus 160. Well, gee, I wonder what that could be. That's going to be 0. 0 divided by anything is going to be 0. Now, here is the point where sig figs crop back up again. And you're probably going, wait, didn't sig figs matter over here? Yes, but it wouldn't have made any sense here because everything had 3 digits. So I'm going to bring it up here. How many sig figs should we have in our answer? Well, we started with 3. And then we used 160, 5, and 9. This looks like we have numbers with only one sig fig. That's not true. Remember I said in the last video that 1 degree Fahrenheit is exactly 5/9 of 1 degree centigrade. These numbers come from that fact. Okay, there's some manipulation going on here to turn it into an equation we can use, but that's where this 5 and this 9 come from. The 160, just trust me on this, is also coming from that. What that means is that the 9, the 5, and the 160 are all integers. Integers. We mentioned that in our our sig figs video. Integers are important. Integers have an infinite number of significant digits. Every digit in an integer is significant. They have infinite sig figs. That means we can write this as 5, or we can write it as 5.0, or we can write it as 5.00, or we can write it as 5.0000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000do changing our sig figs. In fact, every number up here, the 5, the 9, the 160, ditto for this one, the 273, and the 459 are all to be treated as integers in these calculations. What that means is the only number that affects our sig figs is the number we started with. So this has 3 sig figs, so our answer needs 3 sig figs. Now, some of you are going to see this and go, but wait, that doesn't count. Because of how our answer comes out up here, this is exactly 0. Which means that no matter how many digits we add here, everything is going to be zeros. So, to keep track of how many sig figs we are dealing with, we write it as 0.00. This tells anyone looking at it that this is only trusted out to 3 digits. But there's no point in trying to go out and find a spot where it's not 0 anymore. It's supposed to be 0. 0. No matter how far you come this way, it should still be 0. So we write it as 3 digits to indicate to anyone looking at it, hey, this is only a 3 sig fig number. And then the last one here is Kelvin. We want to find Kelvin. Well, this is the equation we're going to use. So 0 plus 273 is going to be 273. Once again, sig figs 3 and 3. Same thing that happened here. It just kind of works out. That's pretty convenient. Now, let's do this one, going the other direction. We need to manipulate this equation to solve it for C, because Kelvin can only be used to find Celsius. So, right now we have K equals C plus 273. We need this by itself. That means we need to move the thing that is on the same side as the C. We need to move 273 to the other side. In order to do that, we need to do the opposite of what 273 is currently doing. Well, currently, it is adding. So we are going to do the opposite of that, which is subtract. So minus 273 minus 273. This goes away, and that tells us that K minus 273 equals C. Well, what is 0 minus 273? Well, it's going to be negative 273. So negative 273. And now we're ready to go from Celsius to Fahrenheit. So we get to use the beast of an equation over here. Wow, that's a small eraser. I keep forgetting this is so small. Okay. So for this one, we're using the top equation. So F equals 160 plus 9 times negative 273 over positive 5. Again, resolve this first. So if we take 9 times negative 273, what do we get? Well, let me grab my calculator, figure that out, and I will tell you. All right, so we plug that into the calculator, and we get that that is negative 2,457. Okay, then we bring our 160 up. 160 plus negative 2457. Well, when you add a negative, you can just subtract. So 160 minus 2,456. And that is going to give us negative 2,297 divided by 5, which gives us a final answer of negative 459.4. But stop! There are 4 digits here. We have to sig fig it before we try to do anything else with it. So, 459.4. If we sig fig this, we had 3 digits. So this needs 3 digits, so the 9 is the last one, which works out well because there's a decimal point after that. So what does 4 make the 9 do? Nothing. So 459. Negative 459 is our answer here. And then, if we take negative 459 and we convert that Fahrenheit number into Rankine, what is negative 459 plus 459? Well, gee golly, I wonder what that could be. It's going to be 0 again. 0 Rankine. Now, this should make sense because 0 Rankine and 0 Kelvin are the same temperature. They are both absolute 0. We talked about that in the last video. Now, this is what I am wanting you to do. Go through and solve all of these. The key is linked here. If you click here, go down and click on key, it will give you the correct answers. There are 3 on here that might be wrong if I haven't had a chance to fix them yet. They're highlighted. So if they're still highlighted, they're still wrong. We will, don't jump around and do all the easy ones. Do 1 row at a time. We did the first row, then the second row, do the third row, then the fourth row, then the fifth row. Don't go, oh, I'm going to do all of these because these are all easy. I'm going to do all of these because these are all easy. And then I'm not going to do any of these until I absolutely have to. Because on the quiz that is coming up for this, it looks exactly like this worksheet, except it's a little shorter. I think there's only 4 rows on the quiz. Might only be 3, but I'm pretty sure it's 4. So you need to be able to do all of it, because if I give you one where it's here, then you're going to have to be able to figure this number out to get this number. Okay, you need to be able to do all of it. So do 1 row at a time, check the key. Do another row, check the key. Do another row, check the key. That way, you're checking as you go. That is going to wrap this video. Have a wonderful, whatever it happens to be, day, morning, night, even, whatever. And I will see y'all in the next one.